Hey there, welcome back. We've deseasonalized this data, we have detrended this data, and we are ready to forecast this data. So if we've got a data series, a time series, in this case on daily deliveries by a fictional food delivery company, and if that data has had all the expected variation, the trend, the expected ebbs and flows due to days in the week removed, theoretically, all we now have is data that exhibits only noise, only the variation that we can't explain. And so it varies due to noise around an average because it's not trending anymore. So all we need to do really is project forward our average down here, which we know is 369,850 deliveries a day. We then backwards adjust for seasonality, and we add back in the trend. So let's get started. We got to get these parameters out of the way. I'm going to take my slope, intercept, and r-squared and cut them, Command X. Bring them over here, paste them, Command V. And I want to take this moment to just remind us that these are our pre-friction parameters. Because we thought, perhaps, that adding friction to the funnel discouraged some good users. And we saw a small change, but there's not enough data for us to really know if it's statistically significant. So because of that, we chose to use the pre-period slope, intercept, and r-squared. I'm going to just label this pre-friction parameters. And then we have our detrended daily averages for each day of the week, the daily index that tells us how large or small the expected delivery number for each day of the week is compared to an average day of the week. And then we have a check here where after we removed the seasonal variation, we were able to calculate the average by deseasonalized day, and they were the same. We were able to successfully move all of the expected seasonal variation. So I'm going to move that over here. Why? Because I got to make my forecast down here. So to make the forecast, for a second here, I'm going to click in the cell T1, and I'm going to go to View, and I'm going to click Freeze Panes. So now I can kind of scroll around, and I can still see those first two panes are locked. DOW number. Okay, that's better. All right. So where we need to go is all the way from this being our last day of real data. We've got to figure out how to make a forecast for some time way down here, November 16th, 2024. So I know I'm going to need to forecast. I'm going to need to make a forecast out in time. I'm going to need to adjust based on that time trend variable, and I'm going to need to add day of the week specific variation. So I'm going to take those cells there, and I'm going to drag them all the way down. I'm going to row to 62 because that's where the 16th of November is going to stop. And we're going to have a lot of lines popping up here and again in the next couple of minutes. So I'm just going to remove all of these lines to simplify things. But somehow we need to remember that right here, October 21st, 2024, that's the last day of our real data. We're going to need to move forward, and we're going to need to add in a forecast that we then add expected daily variation to, and then we need to add the trend to it. So let's add in a new column between deliveries and detrended deliveries. And this is going to be our final forecast forecasted. We'll call it forecast. And we're going to start, if I can spell forecast, we're going to start making a forecast assuming that we don't have the program. Why assuming that we discontinue the program? The reason we're going to start with the assumption that we're discontinuing the friction is because of the choice we made here. Our choice here was to forecast or to estimate the slope, estimate the day-over-day growth in deliveries without the impact of the friction. So our first shot will be to add back in that growth, day-over-day growth, and that will get us to where we would be without the friction. We'll then have to kind of adjust, figure out how much friction how much we should penalize overall deliveries for the friction, and go from there. So, first step, if we've done a good job removing the seasonal variation and the trend, the final data set that is both deseasonalized and detrended can be described pretty darn well as random fluctuation around a constant mean. That constant mean, 369,850, but let's calculate it here. $369,850. That should be our deseasonalized and detrended forecast all the way to the end of the period, or all the way to the end of the reference period. Okay. That's quite interesting. So we're working backwards. These are our weekly indexes. We need those. Begin to introduce funny lines in strange places. Overshoot by a couple of days here because we only want to forecast to a Friday. And now that we have our deseasonalized data next to the expected deseasonalized index, we can move backwards to figure out what those would look like without the trend if they just varied based on our expected level of seasonality. So Tuesday, it's going to be lower than our overall average, so it's going to be equal to the overall average multiplied by this index number. To get from detrended amount to deseasonalized amount, we divide by the index. To get backwards, we multiply by the index. So if we were to just compare a Monday to a Monday, and let's do a Tuesday to a Tuesday, when we divide 108,584 deliveries by the index of 0.57, it increases our number to 190,000. That's giving Wednesday a little boost because normally it's low. We adjust it for its seasonal variation, or its expected seasonal variation. When we come back down, or Tuesday, whatever that is, you know what I meant, and we forecast it at 369,000 as our deseasonalized average, we know that a Tuesday is going to be lower than that, a Wednesday even lower than that. And then the Saturday, we multiply it by 1.84 to give it the boost it needs to show basically to divvy up the week's demand to place it in the places where we expect it to happen. So now we've got a reseasonalized pattern, and without the trend, you'll notice that every Tuesday has the same exact forecast because there's no trend. Now we've got to add back the trend. And the trend we're going to add back, is going to be this slope which matches the growth trajectory before we entered the friction. And so to do that, in our column F, I'm going to take our detrended deliveries, and I'm going to add to that mx. So m is our slope, and x is the time period. So if it had been continuing to grow since we started collecting data at 5,833 additional deliveries per day, we'd have added over this time period quite a lot just in the growth rate. And as we drag this down, we see that Tuesday over Tuesday is no longer the same, because each subsequent Tuesday is expected to have experience. It's expected to be characterized by a market that's grown. All right, this is our forecast as though we discontinue the fraud program, right? As though we allow the pre-friction growth rate to continue. I'm going to zoom out, which I know makes it hard to kind of see things, but I want to add a couple of lines now that make things a little more clear. I'm going to put a top border there, and I'm going to put a top border here. The first one indicates pre and post friction. The second indicates real data to forecasted data. Now let's take fraudulent deliveries and move it to the side, because I'd like to make a plot showing what we've got: existing data, forecasted data. So to do it, I'm going to start by selecting deliveries. Don't grab titles. Insert a line chart. Oops, and actually, let's do all the known deliveries, including the post-friction period. We're going to ignore the titles for now. Let's get rid of those pesky horizontal lines. Let's right-click. We're going to select data. And now series 1, I'm going to name it deliveries. And our axis labels, like what's on the horizontal axis, is going to be all of the dates, including up to the forecast, including the forecast. Okay, we're going to say okay. Then I'm going to select more data. This time, what I'm going to add is my forecast discontinuing fraud reduction. That is not the chart data range, Jamie. That's where the title goes. And my Y values here are the forecast, and my horizontal axis labels, again, are all of the dates. Oh, why? Because I need to include the blank spaces. So we can see that our plot has captured both an increasing trend and the predictable rises and falls. Ugh, I got rid of those pesky labels, but now I'm thinking maybe we need them. How do we put them back? Format plot area, maybe? Never asked myself how to put them back. There, we got it. All right, I'll add titles, labels, etc. And if this is the case, it looks to me like, yeah, we will hit this million mark on that Saturday. Perhaps. And we can see that magic million mark there if we discontinue the fraud prevention program. So let's give ourselves another forecast. And this one we're going to call forecast continuing friction. So how do we adjust for friction? Or how do we adjust for what we think friction might have done to our growth rate? Basically, if friction discouraged good buyers from making purchases, the growth rate day over day would fall. And that's maybe what we saw here, right? This Saturday just doesn't meet the peak of the Saturday before. Well, how do we quantify that? One thing we could do would be to calculate the before or the after, but since we've started in this linear regression framework, one possibility out of many would be, rather than taking our slope in just the pre-treatment period, right, which is basically the line that fits up until we interfere, and change it so that it's now the line adjusted for any decrease in the growth rate that happened because friction caused good customers to turn away. And to do that, we're going to calculate some parameters using all of the data. And the difference in the slope would reflect the reduction in growth caused by the friction. So instead of going E2 to E29, we're going to go to E36. We can also just drag it over and drag it down, which is sometimes the easiest way to do these. And now I can copy. Okay, so our linear regression model thinks that when we take the slope in the time period before we added friction, we got 5,833 additional sales per day. But if we take it for the whole period of time, including the place where we had friction, that slope is lower. We only get 2,763 additional sales per day. And that's why this peak is a bit lower. So rather than adjusting to add a trend back at a rate of 5,800 additional deliveries per day, let's add back a growth rate of 2,763 per day. So if we continue the forecast, if we have a forecast assuming that we continue friction, we would modify this by adding mx, but our new slope is the smaller slope, and x continues to be the daily period that we're looking at. And you can see right away that there's a fairly substantial difference in the values proposed in those two columns. Let's add this to the chart and see how it looks. Because if that's the case, and we continue the forecast, and the forecast has had this, and we continue the fraud prevention program, and the fraud prevention program has impacted our growth trajectory this extremely, we will not expect to hit 1 million by Saturday, November 16th. But let's add it to the chart. Select data, add a new series, forecast, continuing, fraud reduction. Our Y values are the whole column, including the blanks. At least that's what it takes on this version of Excel. And I don't think we have to enter the category labels because I think they're already in there. And there they are. Let's do a little formatting before we chat. If you want these lines to hook up with this line, what you can do is copy the last day of known data into the columns with the forecast, and that should cause them to link up. If you don't want to see them, you can make them white. And then we'll take our chart. We're going to add a title. We're going to add a legend. And we're going to have to make this thing much bigger if we want to see what's going on. And now this is going to be deliveries, and forecasts, and forecasted values. Oh man, I'm not happy with this, but it's what I'm coming up with and without friction. We know what that means, and that's going to be fine. So based on this model, we would assume, or we would think, maybe we'll hit 1 million on November 16th if it's a good Saturday. Like that was a good Saturday, we hit 1 million. But if we want to increase the probability that that's going to happen, we should probably not continue with this fraud prevention, right? There's that trade-off between doing what would strengthen the bottom line over time, probably most effectively, with trying to hit a metric before going public, which is a bummer of a trade-off, but it might only be, foregoing the benefit of reduced fraud for only a couple of weeks. So that's where I'm leaving this one off. And I'm going to zoom out and look at this beautiful spreadsheet that we have made. And that's about all I can do to see all of it. I like to see my whole spreadsheet before being done. Oh, and my laundry's done too. Look at me. Happy afternoon. All right, I will post this. Let me know if you have any questions. And I may come back with an example of how to do this using linear regression, which I think is actually a lot easier. Okay, talk to you soon.